So this micro teach is going to be about graph introduction. So what is a graph? So graph is a set of nodes, also as known as vertices connected pairwise by edges. So this is one called drawing here, but we'll kind of go through more examples in the next slides. So this is more specific examples here. So going over some graph terminology. So here, so graph is, like we said, it's consisted of set of vertices, aka nodes, and also we can say set of edges, which is a pairs of vertices. So you can see that these are the vertices, the circles are our vertices, and then remember that there's only one edge here, right? Between these two pair of vertices, right? Then there's an edge. And if you want to, both terminology, nodes and vertices are okay, because I know back in 143, we mainly like called it as a node. So that's also fine. It's really up to you which terminology you would like to choose. Also, vertices with an edge between or adjacent. So what it means is that let's look at this specific example that we have been seeing. So vertices here, right? And with an edge, and we can say they're adjacent, right? Because adjacent means just like you're kind of next to, like adjacent to it, right? So then you know that you guys are kind of connected by this single edge. And also you can say that the degree of vertex is the number of edge directly connected to it. This is pretty interesting because sometimes you need to figure out how many paths or how many edges am I connected to, right? And you'll see more complex examples later in the quarter. Here, this is one clear example that this vertex is on degree of 3 because you have 1, 2, 3, right? So you can kind of think, okay, it's the number of edges directly connected to it. There are 3 of them if I'm at this node. So that's just one terminology you should be aware of. And lastly, those two things are a path is a sequence of vertices connected by edges. So it's like the word says. So path is just um, we're path is just a point A to point D, like point B, the how we're trying to get there, right? And we need to find a path to get those, right? So shortest path, longest path, fastest path, whatever path, right? So you can kind of see that here. This is a path of length 4 from here to 1, 2, 3, 4. You could have done you could have done 1, 2, 3, but this just drawing was length of 4. And here you can see that sometimes graphs some type of a cycle, like in this clear example. So what cycle really means is that it's a path whose first and last vertices are the same. So you can see that from here, like this person A starts to run away from some scary ghost, and then you can kind of running around and keep getting the same spot. And then the person be like, okay, I thought I passed this point, but I'm back here because there's a cycle. So you're stuck there forever. So good luck with that, right? And a graph with a cycle is called cyclic. And graph that doesn't have a cycle is called acyclic. So, okay, so this acyclic graph it can be consisted of directed and undirected. So as you can see, when I first time saw this, I was a little confused. So you need to look at it a little bit closely, but you can see that in a cyclic graph, what's happening is actually there is no cycle. Because from just like big point, if you just scan it, you'd be like, wait, what? It looks like it, right? But if you see it, the starting point is A, but then there is no way for B to come to A or C to come to A, and you can see there is no way for D to go back to A if A is a starting point, and if starting point is B, that is still the same because from B to D, you can go there because the edge is pointing to D from B to D, but that's the final destination. So yeah, so you can see that if there was a connection between, there's an edge between A and D, then it would be cyclic, right? But there's no edge connecting between A and D, so then therefore it won't be cyclic. And undirected is more clear, definitely, that we usually represent by the arrow that is being directed. If it is undirected, then it's just straight line. One way you can think about is, so sometimes there's when you're driving, that road can, because you know some roads that are in some neighborhood, then you can either just, it's kind of shared by roads like this going down, that's coming up up the hill. We sometimes have to we just share the road, right? You can kind of think this undirected. Whereas if you go on a highway, there's a clear direction that you need to like only the incoming traffic are like going to, I don't know, I-5 or going into this direction, and then whatever that's coming back from Tacoma to Seattle will be taking another clear lane because the car shouldn't crash. So then in that case, we need a directed graph. So another thing here is cyclic. So this one is definitely more intuitive example, I think. So it means like there is a cycle like the name conveys. So you can see that if you start from A, you can get back to A through A, B, D, C, right? If you start from B, in fact, you can get from B, C, A back to B. So there's a cycle. And if it's definitely more clear when it's undirected, right? And one thing I want to lastly mention is as we understand what it means to be cyclic, acyclic. So here we can say that there are three connected components because connected components means that like how many are connected as a whole graph, right? So you can see that from this graph, you cannot reach this graph, right? Because there is no edge connecting to these two graphs. So that this is a sometimes they use a strong, I heard of a terminology called like strongly connected as well. But in this class, I guess we'll use the word connected components. So then here you can say that this is on its own island, and this is on its own island, this is on its own island. So there are total three connected components. So I hope you can make clear distinctions between them.